In this section we're going to look at network topologies as well as network types. Now before we start our discussion, let's get a basic understanding of what a network is. A computer network can be defined as all the communications media, such as our guided and unguided media, devices and software that we need to connect two or more systems or devices. Now whenever we talk about a network, we need to refer to a term called nodes. Now any device, whether it's a computer or a network device that's connected to a network, are typically referred to as network nodes. And network nodes can share data, information and processing of jobs. Now why do we need computer networks? Computer networks enable us to share hardware, programs and databases, but it also aids us in completing our work processes and to collaborate on various projects with other individuals. We find that because we are geographically separated from other countries and other regions, especially now with businesses, that networks enable businesses to now more closely collaborate and share information and ideas, and indirectly helping them achieve their business strategies. Now let's start by looking at network topologies. A network topology can be defined as the shape or structure of a network that indicates how communication links and hardware devices are arranged on that particular network. Now please take note that we are going to refer to various definitions, so it's important to understand what we mean with a network topology, the diagram, versus let's say a network type, which we're going to do in the next section. So we typically find four network topologies. You get the star network, ring, bus and mesh. Now we're going to go and look at each one of these in a little more detail and talk about the way in which communication takes place, as well as some of the advantages and perhaps disadvantages. So let's start with the first one, the star network. If you look at the picture here at the bottom right, you will note that all of the computers are connected to a central device. Now this is typically called your central hub. The hub will receive information, so let's say I want to send information from computer A to computer B. Computer A will send the information to the hub. The hub will amplify the information, the signal, meaning that it's going to make it stronger, and then it's going to forward that message to the receiving computer. Now the advantage of a star topology is that it's relatively easy to lay out and to modify it. And we typically find that this type of topology comes around in your home networks. The disadvantages are they require the most, or they are the most expensive because they have the most or greatest amount of cabling. The failure of the central hub can actually cause the whole network to fail because nobody would be able to communicate. And then if any of the nodes fail, only that node would be affected. So the rest of the nodes would still be able to communicate. So the main things is it's relatively easy to create and layout, but it's costly, and failure of the central hub can cause total network failure. Let's move on to the ring network. The ring network is positioned in such a manner that all of the computers need to be linked to each other. So if you're a computer on this network, you need to know who's your neighbor to your left as well as who's your neighbor to your right. And that applies to everybody. Neighbor to my left, neighbor to my right. So what we typically find is it's going to take what is known as a token. Now a token can be seen as something like a shoebox. So whenever you want to send a message to your neighbor or to anybody in the network, you need to wait until you receive that token, put your message inside, and then you pass it along in the network. So if there's no token, then you can't send a message. So messages typically follow or flow in one direction. So imagine we've got a imaginary token flowing around. So the token will pass around all the computers. The computer will check the contents of the token. If it's empty and it doesn't want to do anything or send anything, it's just going to pass it to its neighbor. If it has a message and it's intended for that particular computer, it will take the message and clean out the token and forward the empty token to its neighbor. Or if it perhaps received the empty token and it wants to send the message, then it's going to place the message inside the token and then forward it to its neighbors. So messages typically follow or flow in one direction. The regeneration process, similar to what we had before, where it amplifies the signal. So with regeneration, when it detects that a signal or token has become, the quality has gone down, it can actually go and strengthen that message in that token. Ring topologies require very little cabling when compared to some of the other topologies. The problem is, if there's a failure of a node, it can actually cause the whole network to fail. So we need to keep track of that. Alternatively, we do find a concept known as self-healing rings. Now, it actually works in such a manner that a token will be passed, let's say, in a clockwise manner, and another one will be passed in an anti-clockwise manner. So if something happens to, let's say, one device, then continuously information can be sent along. The disadvantages, it's very difficult to modify, and the reason is whenever you add a new computer or remove a computer, you need to ensure that the neighbors on both the left and right side of that device are informed of such a change. Token passing is also used to regulate traffic, meaning that not everyone can dominate the network and misuse it, so you actually need to wait for an available token and everyone is granted equal access. The next topology that we find, is the bus topology. Now this is perhaps one of the more popular topologies that we find in many companies. The bus topology uses an open-ended line, also known as the backbone. Now if you remember what we said about fiber optics, fiber is typically used as the communications medium for the backbone infrastructure. So imagine in this network we can have a fiber optic cable here and then other cables connecting to that backbone. Now what are some of the advantages? It's the easiest to extend, so it's relatively easy to add new computers. You just plug it into an available port. It has the simplest wiring layout, and then all nodes, all computers receive the message at exactly the same time. So if I broadcast a message, it's going to be sent to everybody. Everybody will evaluate that message, check whether it's intended for them, and if so, it will look at the message. If not, it's going to disregard that message. The disadvantage of the bus topology is that whenever a fault occurs, it's very difficult to go and allocate or to locate that particular fault and to fix it. Now the last topology that we're going to refer to is known as the mesh topology. The mesh topology, and again if you refer to the image, is a topology where computers are connected, or where nodes are connected to other nodes, and where we've got a lot of cabling. So mesh topologies can either be partially connected, or it can be fully connected. A partially connected topology would be something that we have in front of us here, where computers might be connected to one or more other computers or other nodes. A full mesh network would have meant that all computers, all nodes are connected to all other nodes. Now, mesh networks provide the shortest routes between any nodes. They can also provide alternative routes if there's an issue with a particular route, and we call that situation message hopping. So let's say, for example, if I need to send a message from this computer to that computer and for some reason that connection is lost, it can send a message to the other computers, and then that message can be hopped until it reached the destination. Mesh networks perform very well in heavy traffic because you're not limited to one message, and you're not limited to having a bunch of messages coming in and out. And we do typically find that with most wireless area networks that we use partial mesh designs. Now let's continue and talk about network types. Now, as with the previous section, network topologies, with network types we need to realize that there's various versions, and we need to understand when to use each of these versions. So we typically find that there's 4 major categories. Personal area networks, or also referred to as PAN, local area networks, LANs, metropolitan area networks, MANs, and then wide area networks, WAN. Now we're going to look at each one shortly and then talk about some of the technologies that you can find to work in that particular network. So if we look at a personal area network, that's typically a network that you would find around an individual or in a very closed environment. So let's say, for example, you want to share files on your cell phone with people around you. You can use a communications technology such as Bluetooth, and you enable or you open the connection and they will connect to your device and you will share information with them. It supports the interconnection of all devices and exchange data between computing devices. We are limited to a region of roughly about 10 meters. If you think about the limitations of Bluetooth, it ranges between 3 and 10 meters. And we typically find it where people connect laptops, digital cameras, portable printers and other wearable devices without the need of cables. The next network type that we have is known as local area network. And again, this is typically what you would find in libraries, offices and computer laboratories. So this will connect computers and devices in a relatively small area. It allows users to share data, any computer devices and other resources, and typically we find that it uses guided media in the form of twisted pair, coaxial cables or even fiber optic cables. In many instances we find that people that use LAN networks set up peer-to-peer networks where each node can operate independently but they can still share files with each other. No server is required, so nobody needs to take control of the network, and it's pretty much an open network that you allow for sharing information. We also do find that we get wireless local area networks, and this pretty much started since the development of Wi-Fi, where you can have a router that's enabled or that's connected to the internet, and all the devices can connect through Wi-Fi to that particular router and you establish a small home network. The third network type is a metropolitan area network. Now if you take note, every time when we go to a new type the network actually becomes a little bigger. So with metropolitan area networks, it's where we connect users and computers in the geographical area similar to that of a campus or a city. It might mean that we have a lot of networks in the city that we need to connect to one. So let's say for argument's sake we've got a city like Joburg or Cape Town, and we create a municipality network where all the districts, all the municipalities are actually linked to that major metropole. It combines technologies or smaller networks such as LAN and fiber optic technologies. And it's typically when organizations want high-speed data transmissions, or where you have a consortium of users or network providers that want to set up a network. The last network that we're going to look at is a wide area network. Now, wide area networks are actually the largest network types that we do have, and these can typically be anything, all the networks in a country, in a continent or around the whole world. So there's various approaches or views on what can be considered a wide area network. So it's a relatively large geographical area. It can be privately owned or rented or public spaces. It is usually a combination of multiple LANs and multiple MANs that are connected together to form this wide area network. We can find that we have different types of hardware and transmission media that we use. So perhaps the difficulty with these types of networks is we need to make sure that all the different topologies that we've mentioned before and all the different network types can actually efficiently communicate with each other. Nowadays we find that with wide area networks we can actually make long distance phone calls and access the internet easily, and we can also transmit and receive information across cities and countries, and this is also referred to as trans-border data flow. Now typically we're not really concerned with trans-border data flow, but if you think about certain countries where there's a lot of laws and restrictions, they might have specific guidelines about what is allowed into the country or out of the country. So this concludes our discussion on network topologies and network types.